In this example, we are going to look at an example of what I'm calling mixed factoring practice. So now that we've learned about all different types of polynomials that can be factored, we need to be able to understand which pattern we're going to use with any given polynomial that we're trying to factor. So let's look at this polynomial we have here. I have to factor 2a squared minus 162. Now, like I said, we've learned a lot of different patterns for factoring. So we need a way to keep it all organized. This flow chart is going to be extremely helpful for you as you are working through factoring all these different kinds of polynomials. It's just a roadmap for you to follow so you know which patterns to use and what clues to look for. So always, 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 first and foremost, you want to scan your polynomial and look for a GCF. It doesn't matter what kind of polynomial you're factoring. Your first step should always be to look for a GCF. So in this problem, I notice that the GCF is 2. So after I factor out the GCF of 2, I'm left with the binomial a squared minus 81. So that brings me to my next question on my flowchart. How many terms does a polynomial have? Well, it has 2 terms, a squared minus 81, because now that's what I'm focused on factoring. I've taken out the GCF, so now I'm focused on a squared minus 81. Okay, the question next asks, do the terms contain only perfect squares or only perfect cubes? Well, I have squares because I have a squared and I have 81. Those are both perfect squares. So if I look at a squared and I look at 81, I want to figure out what was squared to obtain each of those terms. Well, it was just the plain letter a being squared and the number 9 being squared. Now, I notice that there's 2 choices in my flowchart under the squares tab. So I need to decide if this factors to a difference of, if this is a difference of squares or if this is prime. Well, this is a difference of squares, which means it's going to factor to conjugates. Notice how it's a plus b, a minus b. Those are what we called conjugates earlier in the semester. And the reason I know it's going to factor to conjugates is because we had a difference. It was a squared minus 81. Notice the one that's prime is plus. That's a squared plus b squared. Okay, let's continue. So now I need my a and now I need my b. My a is my a because it happens to be the same letter, and my b is the 9. So this factors to the 2 on the outside and then a minus 9, a plus 9. I could have put a plus 9 first and a minus 9 second. It doesn't matter. So I'm pretty confident that's my answer. What I'm going to do now is check it. And once you check it, it's so powerful how powerful the check is. I want you to understand, because once you check it, that's, I think, how you really solidify your learning. You're like, oh yeah, I see why this is the answer. So in order to check, we would first multiply the binomials. So I'm going to do FOIL. That's going to give me a squared plus 9a minus 9a minus 81. Well, look what's going to happen to my middle terms. They're going to cancel out, and I'm just going to be left with 2 times a squared minus 81. Then if I distribute the 2, I get 2a squared minus 162, and that matches my original polynomial. So I know that my final answer of 2a minus 9, a plus 9 is in fact the correct answer.